First one theory is VSEPER, which stands for valence shell electron pair repulsion theory. It is basically arrangement of molecules simply on the basis of electron pairs. You have already in detail read about it in BS level and BSc level. Still, if you have some confusion, you can discuss with me, but the main postulates are for this theory are the arrangements of electron, the repulsion stereochemistry of an atom in a molecule is mainly determined by the repulsive interactions among all the electron pairs in valence shell. For explaining the shapes of covalent molecules of non-transition metals, some rules you have to follow. Number one, both the lone pairs as well as bond pair participate in determining the geometry of molecule. Number two is electron pairs are arranged around the central atom, so they have maximum distance and minimum repulsion. Third one is the non-bonding electron pair, which is known as lone pair, occupies more space and it will distort the structure of the molecule. Fourth one is the influence of bonding electron pairs decreases with increasing electronegativity. For example, in water and H2S, bond angles are different due to the electronegativity difference of central atom. Fifth one is multiple bonds behave like single bond in determining the shape of the molecule. You have example of sulfur dioxide and stannous chloride. Stannous chloride is also V-shaped and sulfur dioxide is also V-shaped, but in sulfur dioxide there is multiple bonding, which is double bond between sulfur and oxygen, but it is considered as single bond when you determining the shape. The last one postulate is repulsion between the lone pair electrons are greater than those between the bond pairs. Maximum repulsion is between lone pair, then intermediate is lone pair bond pair, and last one is bond pair. On the basis of these postulates, the shapes of various molecules determined depending on AB2, AB3, AB4 till AB9. They have different shapes. For AB2 type of molecules where two electron pairs are present and both are bonded pairs, then the linear shape is expected. Examples are beryllium chloride, you can say, and nitrogen NO2 molecules. Then AB3 type, where all the electron pairs are bonded electron pair, trigonal planar structure is obtained. Sulfur trioxide is the example, boron trifluoride you can say is the example. Then AB4 type tetrahedral structure is obtained. CH4 molecule is the best example for it. But it has the second postulate also, which says that if lone pair comes, then distortion will occur. For that, one electron pair, like ammonia example, you have pyramidal structure. If two electron pairs are lone pair, then water example, V shape. If three lone pairs, then linear shape is expected. When total electron pair is 4, from which 3 is lone pair and 1 is bonded pair, then the shape will be linear. Next is AB5 type, where trigonal bipyramidal shape is obtained, and electron pairs, if all of them are bonded, then two types of positions. One is equatorial and second one is basal positions. The lone pair will occupy the top axial positions, and they will not in the equatorial positions. In AB6 type, SF6 example, octahedral shape is obtained. In AB7, pentagonal bipyramidal shape is obtained, and in AB8, square antiprismatic shape is obtained, and AB9, trigonal tripyramid shape is obtained. You can get the examples from the notes which I have sent you, and they have detailed about their structures and their geometries and how you can draw their shapes, electronic configurations. Read from these things, and VSEPER is the initial theory. It has many limitations because it does not explain the magnetic behavior, neither the coloring behavior of the molecules, then how the bonding occurs, what are the configuration, why bond lengths are equal, many discrepancies it has. Then VBT came. VBT is basically hybridization theory, which says that before bonding hybridization occur, which results in equivalent level bonds. Um, for example, in carbon, S and P orbitals are involved in bonding, but before bonding, they hybridize together to form sp3 hybrid orbitals. Then bonding occur. The equivalent nature of the bond and equal bond angles can be explained by this theory, but still it has problems because it does not explain the color behavior actually, and how the different chemical mechanism, different chemical reactions are based on structure. That are the limitations of VBT. It cannot explain these things. Then MOT came. MOT can explain color behavior and magnetic behavior. It is superior to VSEPER and VBT, and it explains the structure well. It also explains biacceptorability of the ligands. That's why it is more adopted, and nowadays MOT and CFT are basically used to explain structures of not only simple molecules but also complex molecules of coordination type complexes.